الله الرحمن الرحيم. إن شاء الله نبدأ الجلسة الثالثة عندنا النهاردة في المؤتمر. النهاردة بإذن الله معانا الأستاذة الدكتورة هدى حافظ، عميد كلية العلوم جامعة مدينة السادات. معانا الأستاذة الدكتورة هالة عبد العال، الأستاذ في معهد الدراسات والبحوث البيئية جامعة مدينة السادات. ومعانا الدكتورة هبة عسكر، مدرس بكلية الحاسبات والذكاء الاصطناعي جامعة مدينة السابعة. طبعا النهارده انا ليا ملحوظه جميله قوي، ملحوظه رائعه وبشكر فيها الساده الافاضل المنظمين للمؤتمر، لان لو حضراتكم لاحظتم والمتابع الجيد للجلسات والمحاضرات اللي تم القائها هتلاقيها مسلسله ومرتبه وبتخدم بعضها البعض. يعني ربما يكون كانت المحاضرة الأولى المحاضرة خاصة بيا، وعملت فرشة كاملة خاصة بسلامة الغذاء وعلاقته بالذكاء الاصطناعي. ترتب عليها الأساتذة الأفاضل الدكتور عمرو اللي أفاض وأعطانا مجموعة من التجارب الواقعية والحقلية اللي موجودة حاليا على مستوى العالم، وبعده الدكتور محمد حنفي تمام اللي وضح لنا حاجات كثيرة قوي عن تكنولوجيا المعلومات وعلاقتها بسلامة الغذاء. وتلا ذلك الأذرع المختلفة الخاصة اللي بيعتمد عليها الذكاء الاصطناعي عشان يخدم سلامة الغذاء، وخاصة الكوانتم تكنولوجي اللي أطلع علينا بيها العالم الجليل دكتور فريد النجار، وطرح موسوعة رائعة وفرشة قيمة جدا للكوانتم تكنولوجي اللي هي ذراع مهم جدا جدا لاستخدام الذكاء الاصطناعي في سلامة الغذاء. وتلا ذلك الأذرع الأخرى استخدام النانو تكنولوجي. دكتورة هدى حافظ ازاي بستخدم النانو تكنولوجي واربطها بالذكاء الاصطناعي عشان تخدمني برضه سلامة الغذاء. وتلا ذلك برضه الدكتورة هبة عسكر اللي هي مش بس اتكلمت، لان المؤتمر بتاعنا النهارده على سلامه الغذاء، لا ده اضافت لنا كمان الفود سيكيورتي. يعني اتكلمنا عن الفود سيفتي، وهي اتكلمت كمان عن الفود سيكيورتي اللي هو الامن الغذائي. وده من الحاجات المهمه جدا الخاصه المهمه اللي هي امان الغذاء وتوافر الغذاء والاخطار اللي بتاثر على الامن الغذائي اللي هو في النهايه بيكون اساس التعامل مع سلامه الغذاء. النهارده او في الجلسه الاخيره بنقول لكم مفاجاه جميله، وهي وجود عالم فاضل جليل، عالم مصري بيعتبر من العلماء الافاضل والطيور المهاجره خارج مصر، الاستاذ الدكتور سمير الخبيري. وده عالم فاضل جليل حصل على الدكتوراه في عام 94، وهو استاذ هندسة ميكانيكية وهندسة طيران. حصل على الدكتوراه في عام 94 من أمريكا، الولايات المتحدة الأمريكية، جامعة أيوة. وكان له شراكات وعمل دؤوب وعمل كبير جدا، لأنه من خريج أساسا خريج الجامعات المصرية، بكالوريوس في الفنية العسكرية من القوات المسلحة، ماجستير في هندسة الطيران من جامعة القاهرة، وله شغل كتير قوي في مجال الطيران والهندسه الميكانيكيه المتعلقه بهندسه الطيارات والتبريد والتكييف والهندسه الميكانيكيه للمركبات الفضائيه على مستوى العالم في عدد كبير من الشركات الكبرى في الولايات المتحده الامريكيه. وجود النهارده هيساعدنا وهيكلمنا النهارده عن الذكاء الاصطناعي والتطبيقات الهندسية، وكمان هيضفي تجربته أو أبحاثه عن تقنيات استخدام النانو تكنولوجي في مجال سلامة الغذاء. فليتفضل سيادته. تفضل دكتور سمير.
شكرا جزيلا. أنا يسعدني شرف أن أكون معكم، وبشكر إدارة المؤتمر الدكتور عادل والدكتورة هالة على دعوتي للحضور يعني. وإن شاء الله هنتكلم على مجموعة من التوبكس كده عشان نتكلم في شكل. هعرف الأول طبعا من ميكانيكال انجينيرنج وإيروسبيس انجينير فالفود بالنسبه لي يعني باكلها كل يوم، بس انا بتكلم عليها شويه. فده الاوتلاين of our talk today. First, I introduce myself, then I talk about food safety, food storage and cooling, and nanotechnology applications, Internet of Things in food safety, artificial intelligence applications, recommendations for using artificial intelligence to secure food safety. وفي الآخر هقدم example to include all these things as self-sufficient smart device. ده my self يعني. انا زي ما الشيخ الدكتور قال ايوه سيكل بيرت 94 وماجستير هندسه طيران وانا في القاهره 83 ومتخرج من كليه التنميه العسكريه سنه 74. تخصصي aerospace engineering but my PhD was in mechanical engineering. My experience I have like 50 years experience. اول في الاير فورس حوالي 20 years وبعدين بين الاندستري والاكاديميا حوالي 30 سنه. فاشتغلت في شركات كثيره في امريكا زي رولز رويس، كرين اير سبيس، جنرال داينامكس، هاملتون براند، فيرجستروم سيستم. All these companies in our global stage حاجه كثيره من الانجليزي. اشتغلت في جامعتين في امريكا، ايوه سيتي يونيفرستي اللي انا خدت فيها البي اتش دي، واشتغلت اخيرا في نورث ايرلاند يونيفرستي. الاثنين كنت بدرس في الميكانيكال انجينيرنج. الفود سيفتي by definition we need to have to keep it clean, separate raw from cooked food, cook thoroughly, and keep food at safe temperature, meat refrigerated, and use safe water and raw materials. طبعا قلت اليونايتد ستيتس، فاليو اس ديبارتمنت اوف اجريكلتشر اليو اس دي اي عامل 4 recommendations for food safety to be clean, to be separate, to avoid cross contamination, to be cooked thoroughly at to the right temperature, and to be refrigerated. برضه اليو اس government agencies like FDA الFDA اللي هي Food and Drug Administration require every food facility or food organization or food manufacturer to have a food safety plan. والبلان ديت لازم تبقى documented وapproved و to be valid for 2 years at least. ديت الكونتنت اوف food safety plan to handle hazard analysis, prevention control, recall plan if something happens has to be recalled, the monitoring, everything has to be documented and approved, verification, procedures and corrective action if something wrong happens, validation, and record keeping. In storage, food safety, storage and cooling are essential, of course. Effective food storage and cooling includes refrigeration basics, temperature to be assigned for refrigeration and for freezer. And when we store things in refrigerator, always we put in the lower shelf the raw material, and in the top shelf we put the ready stuff. Freezing, we keep it in certain containers, bags. We label it عشان to follow up التايم بتاعه, freezing time for different materials like meat, 6 to 12 months and so on. Pantry, which is not refrigerated, just to be kept in dry places, and airtight containers to be rotated to follow first in, first out. This is like refrigeration. We put in the lower shelf الحاجات الرو, on the top shelf ready. For refrigeration بيبقى محتاجين refrigerator. الريفريجريتور ديت بتبقى في عندنا different cycles can be used. الريفريجريشن ديت بتبقى طالبه حاجتين. We need electric power to drive it, and we need refrigerant to be circulated to transfer the heat from one location to other location. Usually we'll take it from a cold region to a hot region or a warm region, and this is against nature because always heat will go from higher temperature to lower temperature, but in this case we need to provide warmth. We have to have a compressor and provide the electric power to work against the direction of heat. ففي هنا 3 cycles. الفيبر compression cycle اوريها لكم هنا، هي ديت الريفريجريشن compression cycle. بيبقى 4 components. We have evaporator where is at the cold region where the stuff is safe and will take heat from here, and we have a refrigerant which will circulate. This is the closed cycle, and outside here the warm region where the heat will be dissipated, and here a compressor which will compress the refrigerant in the circle because here will be leaving at cold temperature, and we need to have the refrigerant as it passes through the condenser. The compressor will be compressed and heated up. So when leave, the compressor will be at a higher temperature, higher pressure, which will come through the condenser. The inside temperature of the condenser is higher than outside, so it dissipates. But actually, the outside temperature is higher than the cold region. That's why we need to have this. Cold region temperature usually would be set as the reserve temperature. This is a TS diagram which showing us how the change of the temperature and the pressure and entropy inside the line of the refrigerant. So this is the cold temperature, this is the outside temperature, and here is the between 1 and 2 L we have the compressor. So the refrigerant will come here at this point for like vapor, liquid, and as it passes here and gets heat will be evaporated, comes to point here as vapor, but at low temperature and pressure. Then we go to the compressor, it will be compressed to high pressure. Then will be go to the condenser where heat will be dissipated outside, and then this expansion valve is just a valve to change the liquid into vapor. No water. So the refrigerant arrive here as liquid and as vapor. This is how to calculate the efficiency of the system, which we know as coefficient of percentage, coefficient of performance. It is defined as a ratio between what we gain over what we gain. What we gain here is the cooling capacity, the amount of cooling, and what we pay is the amount of work provided to the compressor. So we have 2 equations here. One is the actual one, because when the refrigerant circulates, it always suffers losses because of friction, because of irreversibility. So when we calculate the enthalpy, which is a property of the refrigerant at these 4 locations, and we get these values from thermodynamic table, will give us the coefficient of vector. But if we consider simplification, that's no losses here and everything is good, then this will be the definition of Tc, which will be the temperature of the cold region over the difference between the Th minus Tc. Th is the temperature of the warm region, and I put here approximate value because they are not equal. Usually this will be higher because we ignore heat dissipation to the outside, which we cannot restore, ignore friction, but maybe this one will be higher, like 10-15%. If I go back, so in this cycle here, we have two things. We have a refrigerant, which is circulating, and we have a compressor. Compressor needs electric power, which will cost us money. The refrigerant will have some effect in global warming, in depletion of the ozone layer. So there are some cycles which try to avoid this, which was these two cycles, but I will not go in detail. Here the absorption cycle, will avoid to have a compressor completely, and we will use ammonia, not a refrigerant. Ammonia as a refrigerant. But the other one has different division, which I will show you in the next slide. But the absorption one has ammonia, and the ammonia has very or no bad effect on the global warming, and also does not need a compressor to compress it. So we will save the electric power that we need to use to run the compressor. The idea here is that we will, after the ammonia pass through the evaporator and evaporated, we'll let this ammonia vapor to go through absorber, which can follow water, and the ammonia will be dissolved in the water, and then will be passed by a pump, and the pump use very limited electric power compared to a compressor. And the ammonia dissolved in water will go to a generator, and the generator will have some heat source and will evaporate the ammonia again, and then the ammonia will go through the condenser to dissipate the heat to the outside. So now we circulated without refrigerant, which is harmful to the atmosphere, and without electric power. The third one here is a Brighton, reverse Brighton cycle, or sometimes called Brighton refrigeration cycle. And this one will not use refrigerant. It will use carbon dioxide or air as the fluid which will transfer the heat. But also will not use expansion valve to transfer liquid into vapor, but it will use instead a curve. I don't have a picture, but the advantage in this one, we don't use a refrigerant, and we still use a compressor. This one is used, it was using carbon dioxide in some recent years when they start to use air conditioning for vehicles using CO2 as a refrigerant. The bad thing when it started this several years ago, I don't know what's happening now, it was need to update the hardware of the vehicles because the CO2 will be raised to a very high pressure. So we need a hardware which will be able to handle this high pressure. Let me now jump here. For the electric power, as we see here in the US in 2013, we have three sources of electric power, all of them are non-renewable energy source. Coal, natural gas, and look at 85 or 87% comes. The other 10% is coming from renewable energy. And the next table here is having the electric sources also in the US in the last 10 years from 2013 to 2023. Still the coal and the nuclear, natural gas and the nuclear are the main sources. The other things is still very limited in comparison. This is the table which I was talking about, the first cycle, the compression cycle, which has the refrigerant here that we are familiar with. All of this is CFC, CFC is the chlorofluorocarbon, which has in the last column here very high global effect. If we look down here for the CO2, it has 1. So this is 1 here, CO2, and compared to other refrigerants like 2000 or 3000, which is very harmful to the environment. The other thing is that this first few here, which starts with C, this is the chlorine, and chlorine is very harmful to the ozone layer. That depletes this ozone layer. That's why air conditioning was kept developing, and refrigeration generally kept developing to avoid using this chloro refrigerant and to minimize the usage of electric power. On the side here, we have to choose a refrigerant. We look for capacity, safety, and environmental aspect. And the ammonia here is a natural one, which is very good. It has effect here in our NH3 0, so has 0 impact on the environment. For this global warming, GWP, global warming potential, this is a number here is telling us how much each one, and we can see that CO2 and ammonia are very small compared to the other refrigerants that we start to eliminate when using. Some of them already eliminated, some still in the process to be eliminated now. This is the different kinds of refrigerants which is harmful. Each one which starts with chlorofluorocarbons, hydrochlorofluorocarbons, and all these are harmful to the environment. The natural ones, which is like ammonia, carbon dioxide, are very friendly to the environment, but have some concerns.
دكتور سمير ايوه 5 دقايق.
شكرا. This is the environment here. We have the troposphere and then stratosphere, and this is the one here, the ozone layer, which we need to have to keep it. Then the second topic I want to talk about nanotechnology, like Dr. Hoda اتكلمت عليها. Nanotechnology is a way of manufacturing material composed of nanoparticles by either grinding it to regular material to particles and then assemble it again, or from bottom up we can evaporate it and deposit again, which will create. This second kind is better because the material will be more uniform. All these nanomaterials have better properties than the original material. Like any material, it will have better thermal conductivity, better density, better conductivity, and so on. Application of nanotechnology, it has many applications. Once we manufacture this material, it has better properties. We have many applications like in biology, chemistry, physics, material science, agriculture, food safety, engineering. Nanotechnology can be able to create many new materials. Okay. Nanotechnology applications to improve food safety. It can be used for food safety, can detect, can use nanosensors like the graphene sensor that Dr. Hoda talked about, which will can detect harmful bacteria, viruses, and so on. Or can be used for contamination removal, which nanomaterial like magnetic can be used to remove heavy metals, pesticides, and from food. Or food packaging can be used nanomaterials also, which like silver nano particles can be used to remove or detect antimicrobial products. Smart packaging like nanosensor can be used for this. It can be used for water purification like nanomembrane, desalination لتحلية المية.
دقيقتين يا دكتور سمير.
شكرا. I hope so. الناس تتميز بيها some adverse effects like toxicity, require regulation to control it, and public acceptance is not well known. Then we go to another one here, Internet of Things, which will use sensors to detect anything we want, like temperature, pressure, motion, and this will be connected to a gateway like a router, which will send it to a cloud, and the cloud has a software which will take this data, analyze it, and give some feedback to the users. IoT use like take data, and the data will be transported to cloud, and the cloud has software to use it and send it. Examples of IoT sensors like temperature sensors, like humidity sensors, like gas sensors, like GPS. All these will be used to provide instantaneous information for which will reach the manager, which will make a decision. The last thing I want to talk, I hope, get 2 more minutes. Artificial intelligence, like many of you have defined it, to simulation the human intelligence, and based on the advances of hardware and the capacity of hardware, we can store now a huge amount of data which will provide this. So at the end, we have a special system designed to operate autonomously, adapting new information and improving over time. Some concepts here, like machine learning. We have several of them, supervised, unsupervised. Many of you have talked about, and that's the same sign here. This is saying if we want, for example, to know how much rainfall will happen at certain area, either using the regular way by physics, solving huge amount of equations, and which will take time and hard, but using machine language will provide data about weather conditions, the amount of rainfall at different locations. Then the system will learn, or the model will learn. Then later, if we give a description of weather conditions at some location, it will tell us how much rain will happen. Deep learning is advanced part of machine learning, but now using neural networks, and this will make fine tuning for data until we get the output. So this is how a network will, neural network, this is a simple example, but showing how we have input here, we have output here, and in the middle here we have layers of parameters which will adjust the input until we get the output. This example here we have 99 parameters, but in real life we have millions or billions of parameters which will solve parts. Benefits of artificial parts for food safety. It can help for early detection and prevention, improve accuracy, enhance customer trust, reduce the regularity burden. Yes, these are examples of companies having applications for using artificial intelligence to help food safety. Like this one here, IBM Food Trust. It can track food from origin to the delivery. Tyson Foods, this lab, LTT, which is specialized in food safety, seafood supply, food logistics.
Time is over, Professor.
Can I take one more minute? Okay. Recommendations for a section. Let me jump this. Using food safety. Yeah, this is another video. I will have the lecture available. You can hear it. This is the example I want to give for self-sufficient village. This was a real example happened here in Egypt in 1983. This Dr. Afi Fatih was my advisor, and he was running this project. We have cattle farm here. We have underground waste storage, which will use this waste of the animals to generate methane. We have here a wind turbine. And then at the end, I want to say this is the example of self-sufficient smart village. I don't use the word smart in the last slide because at this time with no technology, but now we can have a farm which will have all these, including also advanced technology like AI, IoT, and nanotechnology sensors. So this village here will utilize renewable energy, food energy storage, water management, waste management, food security, reduce carbon footprint, communication network. For smart this village has some challenges. Initial funding is a problem. Technical expertise will be an issue. Behavior change an issue, and scalability if we want to utilize this for other. This is the way how the waste of animals will be converted into methane. So anaerobic digestion. So we get waste and will be digested in the absence of oxygen.
أنا بستأذن حضراتكم ندي الدكتور سمير دقيقتين كلام بعد إذن حضراتكم لأنه جاي من أمريكا. استأذنكم يعني. اتفضل يا دكتور سمير.
شكرا جزيلا. Anaerobic digestion will have a sequence of chemical reaction here in the absence of oxygen, which will at the end generate methane and carbon dioxide. Besides the methane, also we have the solid, which will become digested, which can be used as a fertilizer. So the waste of animals here is used completely, either fertilizer or a source of energy. The process of this digestion is just as similar to a glucose chemical reaction, which will exchange the glucose into carbon dioxide and methane. This is the schematic of the digestion storage under the ground, and will get fertilizer and biogas. We usually use at the top here like this subunit wind turbine, which will rotate under the effect of air, because these two surfaces have two different drags, so it will rotate by itself, no power is required. This will rotate slowly, which will circulate the salt waste to help the digestion process. Yes, this will show how smart now, the word smart, will use this new technology, artificial intelligence, in different things here to help this village to work correctly. At the end, I have two recommendations here. One is to apply artificial intelligence to help secure food safety and which will be beneficial for all population. The second one is recommending to implement this self-sufficient smart village as a model to enhance food safety by leveraging technology, sustainable practices, and community engagement. If you have any questions, this is my contact information. Yeah.
نشكر حضرتك يا دكتور سمير على المحاضرة القيمة. شكرا.